Hello everyone, myself Devananda Rao. Today's topic is implementation of three address statements. A three address statement is an abstract form of intermediate code. In a compiler, three address statements can be implemented as records with fields for the operator and operands. There are three types of implementations for three address statements. First one is quadruple, triples and indirect triples. Quadruples. A quadruple is a record structure with four fields which are operator field, argument 1 field, argument 2 field and a result field, 4 fields. The OP field contains an internal code for the operator. The three address statement, for example, the general form of the three address statement, x is equals to y OP z is a general form of three address code. X, Y, Z are the three addresses. OP is the operator. Operator may be any arithmetic operator, logical operator. Represented by placing Y in argument 1. Argument 1 will contain X. Argument 1 will contain X and Z will be in argument 2. That is argument 2 will contain, argument 1 will contain Y. Argument 2 will contain Z and result will contain x. So, general form x is equal to y OP z. Result is x, that is a result will contain x, argument 1 will contain y, argument 2 will contain z. Then how to implement a three address code by using quadruples? We will take an example. A is equals to B star minus C plus B star minus C. It's a given expression. Now we need to convert this expression to three address code before implementing the quadruple. Take T1 as a temporary variable, assign minus C, that is unary minus C is assigned to T1. T2 is B star T1. T3 is minus C, unary minus C. T4 is B star T3. T5 is T2 plus T4. A is equals to T5. A is equal to T5. Now, the quadruple will contain, it is a record structure containing operator field, argument 1 field, argument 2 field, result field. This 0, 1, 2, 3 are specifying the locations in the symbol table. T1 is the result, minus is the unary minus, that is U minus, that is unary minus. Operator is in this, operator in this three address statement, operator is minus, that is unary minus. Argument 1 is C and T1 is the result. So, I will put C in argument 1 and T1 in result. Operator is unary minus. Unary minus operator will be applied to single operand. Here operand is C, operator is unary minus. T1 is the result. Like that we can place all the arguments in this table. Next, three address statements. T2 is equals to B plus T1. Here B is argument 1, T1 is argument 2, T2 is the result. Operator is star. So, put star in the operator field and B in argument 1 field, T1 in argument 2 and T2 is the result. Next statement, T3 is equals to minus 3 minus C. So, T3 is the result, operator is unary minus, C is the argument 1. So, unary minus C argument 1, result is T3. Next, T4 is equals to B star T3. Here B is argument 1, T3 is the argument 2, T4 is result. Operator is star. Operator field contains star, argument 1 will contain B, argument 2 will contain T3, result will contain T4. T5 is equals to T2 plus T4. Here argument 1 is T2, argument 2 is T4, operator is plus, result is T5. Final statement, that is assignment statement, A is equals to T5. Here A is the result, T5 is argument 1, operator is assignment operator. Assignment operator, T5 is argument 1, A is the result. Like that we can implement three address statements in quadruples. That is first method of implementing three address statements. Triples. second method. To avoid entering temporary names into the symbol table, we might refer to a temporary value by the position of the statements that computes it. That means, here in quadruple, we have used temporary variables names T1, T2, T3, T4, T5. So, instead of using these temporary variables, to avoid these variables, we can use these locations, temporary values available in that locations. If we do so, 3 address statements can be represented by records with only 3 fields: operator field, argument 1 field, argument 2 field. There is no result field in the triples. The fields argument 1 and argument 2 for the arguments of OP are either pointers to the symbol table or pointers into the triple structure. Since 3 fields are used, this intermediate code format is known as triples. Here same example, A is equals to B star minus C plus B star minus C. T1 is equals to minus C, T2 is equals to B star, T1, T3 is equals to minus C, T4 is equals to B star, T3, T5 is equals to T2 plus T4, A is equals to T5. Now, triple will contain only 3 fields. The record will contain 3 fields: operator field, argument 1, argument 2. There is no result field in triples implementation of 3 address statement here, but instead of using temporary variables, we can use the location. First statement, T1 is equals to minus C. Here minus is the unary minus operator, C is the argument 1. So, operator field will contain unary minus, argument 1 will contain minus C, and there is no result field. So, the value of temporary evaluation will be available in 0th location. Then second statement, operator is star, B is the argument 1, T1 is the argument 2, but here we are not using temporary variables. That is why we can use the addresses. See, B, star is the operator, we can put star in operator field, B is the argument 1, B is the argument 1. So, instead of using T1, here we can use the location address 0. So, 0th location. Argument 2 is the T1, the result, whatever result is there minus C, that is available in 0th location, that is right here. Next, T3 is equals to minus C, unary minus argument 1, the result will be available in location 2. Next, T4 is equal to B star T3, argument 1 is B, star is the operator. Instead of writing T3, we will get value from location 2, I will write location 2. Next, T2 is the argument 1, T4 is the argument 2, plus is the operator, we can put plus here. T2 will get from address 1, T4 will get address, we can get from address 3. So, 1 and argument 1 is 1, argument 2 is location 3. Finally, A is equal to T5. Operator is assignment operator, argument 1 is A, argument the argument 2 is T5. T5 is available in location 4. Like that, we can implement triples for the intermediate 3 address statements. Next, indirect triples. Another implementation of 3 address code is that of listing pointers to triples rather than listing triples themselves. Here we can maintain an array of list of pointers pointing to the triples. Like that. For example, let us use an array statement to list pointers to triples. Here array statement, it is a list of pointers to triples. Here 3 fields, operator field, argument 1, argument 2, same as triple, but instead of using triples itself, we can use list of pointers to triple. So, array 0, array 1, array 2, array 3, these are indices. So, array of 0 containing 14, that is pointer to triples, 15 pointer to 15, 16 pointer to, like that. Remaining arguments as it is unary minus C, argument 1 is C, that is B star minus C, that is minus C is available at pointer 14, like that. Unary minus C, B star 16 will give minus C, B star minus C. Next, addition 15 plus 17, 15 will give B star minus C, 17 will give B star minus C. So, finally, A is assigned with the value available at 18, that is B star minus C plus B star minus C. This is the implementation of triple, indirect triple. Thank you.